Lesson 16. Links and joints of a robotic arm. Contents. The topics covered in this lesson are: Introduction to robotic arm, Degrees of freedom, Joints and links. The activity for this lesson includes finding degrees of freedom for Vex Clawbot. Introduction to robotic arms. What is a robot arm? A robotic arm, which is usually reprogrammable, is a type of mechanical arm which functions similar to a human arm. It is a system made of links and joints with multiple degrees of freedom, with a manipulator at the end, to perform various dexterous tasks like gripping, picking and placing objects. Parts of robotic arms. Let's talk about the robot arms. A typical robot arm contains upper arm, lower arm, and end effector, which is attached at the end of the lower arm and performs certain tasks like gripping, digging and so on. Applications of robotic arms. On the left is the Da Vinci surgical system. This Da Vinci system can enable surgeon to operate with enhanced vision, precision and control. This is the military application. The inspection robot can use the arm to check if there exists danger on the road. There exists many kinds of arms for various applications. Here we can see military robots with arms used for bomb defusing, or manipulating objects. In an automobile industry, the robot arm can realize the welding on the body of car. They are used in chassis development or car assembly. This is the domestic robot, which is produced by Moly Company. The robot can cook a customized dinner for the master. This is a food industry application. In space, the rovers such as Curiosity are used to explore the surface of Mars. Space manipulators are also used in repair and maintenance of spacecrafts. In space, the rovers such as Curiosity are used to explore the surface of Mars. Space manipulators are also used in repair and maintenance of spacecrafts.
Amazing new generation robots that are used for the production of vehicles, the manufacture of composite materials, or distribution in logic centers. These are the 10 most amazing industrial robots in the world. LR-Mate. It is a robotic arm that is used for waste recycling tasks. The Fanuc company has created this technology in collaboration with the Waste Robotics company. New software scans and recognizes waste to classify them in different containers. The artificial intelligence of the robot allows you to perform the work automatically. This type of software allows sorting waste with multiple robotic arms at the same time. TP-80. It is an extremely fast robot that has been designed to perform operations with small objects. It can be used in various sectors for handling food, pharmaceutical products, or other objects. The size of its arm can allow him to work in small environments and has a range of 31 inches. You can load up to 2 pounds and carry out 200 operations per minute continuously. Laser Snake. It is a laser cutting robot that is used to dismantle facilities safely. Its flexible arm is designed to reach hard-to-reach places through small holes. It works remotely controlled and can be installed quickly anywhere. Its high-power laser can cut thick layers of steel and maneuver inside confined spaces with great precision. Ecto-RP. It's a third-generation paint robot with 7 axes that is used to paint vehicle bodies. It is equipped with multiple sensors and has a great mobility and flexibility. Its design allows you to reach areas of difficult access, such as the interior of the vehicle. At present, many of the leading vehicle manufacturing companies use these types of robots. M2000IA. It is the strongest robotic arm in the world and can lift loads of up to 5,000 pounds. It is used to lift heavy loads such as vehicles or large machine parts. It is equipped with a vision system that allows you to identify and handle different types of objects. You can move and place objects within a large work area with a high degree of accuracy. AFP. It is a new robot that places fibers automatically in pieces that are used in the aerospace industry. It's used to manufacture composite structures such as pieces of aircraft. It is equipped with carbon fiber coils and works by placing layer after layer on the pieces with great precision. This robot allows to manufacture highly customized parts, making the process controllable and repeatable. AutoStore Blackline. It is a new type of logistics robot that is used for product storage. It works by scrolling through the top of a structure while stacking containers with products. Afterwards, the robot picks them up again so that they are packed and shipped to customers. This type of robot can deliver up to 650 containers per hour and work in groups 24 hours a day. Pegasus. It is a new Amazon robot that is used to transport boxes through its logistics centers. It works collecting the different types of individual packages and taking them to the conveyor belts associated with their destination. The use of these robots allows to accelerate the time of preparation of the orders and improve the efficiency in the distribution process. KUKA OmniMove. It is a robotic platform that is used to transport heavy loads such as trains or airplanes. It uses omnidirectional wheels that allow it to move in any direction, even in tight spaces. It can be controlled manually from anywhere or operate autonomously. It has great precision and can carry loads weighing up to 90 tons. Handle. It is designed to palletize merchandise in warehouses autonomously. You can move boxes of up to 33 pounds and move at a speed of 13 feet per second. It uses vision-based software that has a deep learning system to identify and locate the boxes. It can work together with other robots and is capable of moving up to 360 boxes per hour.
Joints. Joints, also called axes, are the movable components of the robotic arm that result in relative motion between adjacent links. The numbering of the joints start from 1 to n. Links. Links, also called as arms, are the rigid structures connecting the joints. The ground or base is also called the base link and considered as link 0. The number of links will be 0 to n1, where n equals number of joints. Types of joints. There are 6 types of joints, namely, prismatic joint, revolute joint, cylindrical joint, helical joint, spherical joint, and universal joint. Prismatic joints. They are also called as linear or translational joints. The type of motion between the links is linear along the prismatic axis of the joint. 1 degree of translational freedom along a prismatic axis. For the prismatic part, the link is supported on a linear slider bearing, and linearly actuated by ball screws and motors or cylinders. Revolute joints. They are also called as hinge joints, which allow rotation along a single axis. 1 degree of rotational freedom about a revolute axis. For the revolute joints, they are often driven by electric motors and chain or belt or gear transmissions, or by hydraulic cylinders. Helical joints. They are also called as screw joints. Its motion is similar to a screw motion, which rotates freely but cannot translate freely, restricting its translational motion. 1 degree of rotational freedom, DOF, along the axis. Cylindrical joints. Its motion is similar to a revolute joint in series with a prismatic joint. 2 degrees of freedom, with one being rotational and the other translational along the same axis. Spherical joints. They are also called as ball and socket joints. 3 revolute joints intersecting at a point called the pivot with rotation in 3 directions. 3 degrees of rotational freedom about the pivot point. Universal joints. They are also universal coupling or hook joints. 2 hinges joining at a point at 90° to each other with their axes inclined to each other. 2 degrees of rotational freedom about the intersecting joint. Degrees of freedom. What is degree of freedom? Number of independent position variables which would has to be specified to locate all parts of a mechanism. In most manipulators, DOF is usually the number of joints, including rotations and straight line movements. DOF equals the number of independently driven joints. The more the DOF is, the more the computational complexity is. The more the DOF is, the more the cost is, the more is the flexibility. For a free body in the space, there are 6 degrees of freedom. 3 are for translation, which are along with the x-axis, y-axis and z-axis. 3 for rotation, which are roll, pitch and yaw. It is important to know, for a given effector, how many total DOF any given robot has. If there is an actuator for every DOF, then all of the DOF are controllable. Usually not all DOF are controllable, which makes robot control harder. As a note, any free object in 3D space, the hand, a fingertip, a car, a plane, can have at most 6 DOF. Activity 1. How many degrees of freedom are there in human arm? Degrees of freedom. Number of ways, rotation, translation about axes, in which the motion of the system can be actuated, motors, linear actuators. Solution. A human arm has 7 DOF, which includes 3 in the shoulder, 1 in the elbow and 3 in the wrist. Remember that a free object in 3D space, the hand, the fingertip, can have at most 6 DOF, so there are redundant ways of putting the hand at a particular position in 3D space. How to calculate degrees of freedom for a robot? The following formula describes how many DOF a robot has. Constraints on joints. Joint constraints. They are used to restrict the relative motion between the 2 components at a joint. They result in the decrease of the degrees of freedom of rigid body system. Types of constraints. Planar. Motion constraint placed by one body on another in 2-dimensional space. Spatial. Motion constraint placed by one body on another in 3-dimensional space. This table provides a summary of the joint constraints on all the 6 types of joints in planar and spatial coordinates. Activity 2. Using the formula, calculate how many degrees of freedoms are there for mechanical arm in Clawbot. Activity 2 solution. Vex Clawbot has only one revolute joint in 3D space. So m equals 3, n equals 3, c equals 5 and I equals 1. Degrees of freedom equals 1. Thank you.